Hey everybody, welcome back to New Videos channel, and today we look into the new Vue 3.6 Alpha 1 and what it brings for you. Here we go. Whew, this week was one of the busiest in the Vue.js ecosystem for a while, I would say. There was VueConf China happening and a few things got released there. The Vue dev tools are open source. Nuxt Labs got acquired by Vercel, and Nuxt 4 is out now too. But that's not all part of the video. Might do separate on these. Today, we want to talk about the latest Vue 3.6, not release, but alpha release. Before we do that though, a quick word from the sponsor of this video. Time to jump into the front-end world and experiencing life in Japan? Yes, that's your chance, because Henge is hiring a junior front-end engineer to help building the future of their cloud services. You could do all that while working in the vibrant Tokyo. As a junior dev, you have quite some responsibilities and you will learn a lot, I promise that. But besides learning, you will implement high-fidelity UI with Henge's design system using Vue.js, right, the framework we all love. You will deliver high-quality code, and yes, with testing, right? Good development practices, CI/CD, and even writing documentation. No joke. Of course, collaborating with other teams, that's a must-have as well, and supporting teams through active discussions and code reviews. All in all, you don't have to learn Japanese because you work in an English-first international team, and flights, visa, and relocation support is also provided. So, that's your chance. Apply through the link, go to lichter.link/Henge Junior, also in the description below, and go for it. Best of success, and back to the video. Okay, let's unwrap this Alpha 1 release of Vue version 3.6. It's not that much actually to unwrap. There are a few bug fixes. Then we have performance improvements and features. So let's go from top to bottom. The biggest feature landing in that alpha is Vapor Mode. Yes, you heard it correctly. It happens. Vapor Mode landed in a Vue alpha. So we're on the right way here. And it has been around for so long, the term Vapor Mode. I even have that picture of the Year in Review 2022 post on the official Vue blog post in mind, where Vapor Mode was extensively discussed as a concept to explore. And after a lot of work from quite some contributors, we see that it's finally here. Before jumping into Vapor Mode, let's have a look at the second big thing under performance improvements here, which says Reactivity, refactor Reactivity core by porting alien signals. And some of you might have seen my video about alien signals back then, when Johnson was pushing out, well, performance improvement after performance improvements, eventually landing in this wonderful library called Alien Signals. And here we have not only the cute logo, but also the points of inspiration, like propagation algorithm of Vue 3, pre-X double-click list approach, in-effect scheduling of Svelte, and graph calling approach of Reactively. This altogether made its whole thing to version 2, and now the concepts that were used in this wonderful signal library are now also ported into Vue. The important part is that actually there is no breaking change, so that's also why there's no Vue 4 or similar. This is all being done and being improving performance while keeping the results the same, which is pretty impressive. So just for someone who doesn't know the context, as a TLDR, Johnson, the creator of Volar and the Vue extension for VS Code, he wanted to have a single library and he built the fastest one out there. This lovely chart here also shows the comparison between Alien Signals 1.0, not even 2, that's a bit faster, even in Vue 3.4. So here we also see that some operations take way longer, right, in Vue 3.4, and they will be way faster now in 3.6 because Alien Signals has been ported over, especially due to the fact that it works even more performant with a lot of reactivity nodes compared to the Vue version. People using a lot of reactivity might see more improvements in terms of less CPU cycles and memory reduction compared to a very simple demo application, of course. And yes, I casually brushed over the fact that Alien Signals is the fastest single library out there. That's measured not by me, but by someone who's doing a reactivity benchmark in JavaScript called Transitive BS in this case. So shout out to Travis Fisher for maintaining that and eventually checking different frameworks and libraries. And if we check out the chart, then we will see this wonderful chart, just inverted so you don't have a big flash here. And the slowest library here is actually the TC39 Signals polyfill. Yes, Angular Signals here seems to be way slower, And for this benchmark, that's correct. But in practice, Angular is using Angular signals a bit different than the test cases here. So in practice, Angular signals in Angular are roughly as fast or slow as Vue's reactivity system. Rough, like give or take a few numbers. Still, in this test, they are the slowest, but in practice and in actual real-world applications, they might not be. But still, we have other libraries like Solid.js in here, Preact signals, Svelte 5 being top 3, Reactively, and then with a big gap, still to number 2, Alien signals. So that's pretty amazing. And once again, the best part is this library is available for everyone to use, and framework authors are able to port certain changes over if it works for the system. So this is once again a great thing for the whole JavaScript ecosystem. And actually not only JavaScript, because Alien signals got ported to Dart, Lua, Luau, never heard of Luau, wow, Java, C#, and Go. So it's now even a multi-language library. Great job, Johnson, and once again, thanks for making things better. So this is coming to Vue 3.6. And of course, now it's time to dig into the Vapor mode. So some of you might have wondered if Vapor mode, given that it was talked about so long, is vaporware, but luckily that's not the case. Also at this moment, shout out to Icarus GK for this lovely graphic that he generated. And yeah, it is finally coming, but what actually is it? What is Vapor mode? Is it a new API? Do we have to be concerned of the composition API, the options API, and the Vapor API? No, don't worry, that's not the case. Vapor mode is just a different way to compile using file components. So technically, your API will stay the same as long as you use modern parts. It's fully opt-in, so you don't have to use it, and it's perfect for performance-critical parts of the application. Performance-critical means something like gazillion rows of data, like data tables or data visualization, charts. That's perfect, where you need to render a lot of DOM nodes at once. You also can build your whole application in Vapor mode at once, but it is a bit more limited. And to have a look at Vue Vapor, we can straight away go into the Vue.js playground. We have to make sure that we update our Vue version here to 3.6.0 Alpha 1, or if there's later version available, use that, and we can try it out. Now, nothing is different, and we can see that by checking the JavaScript output. And here we can say this is the same as before. Even if you would switch back to 3.5. whatever, this doesn't really change much here, because this is still the good old virtual DOM approach. Because if you didn't know that, Vapor means that your components will not use a virtual DOM anymore. So if you write your whole application in Vapor, no VDOM. The idea was that Vue 1.0 back then had no VDOM and just walked across the DOM and filled out string interpolations, directives, etc. A bit what Petite Vue is doing nowadays, or Alpine.js and other libraries. Vue 2 introduced then a virtual DOM to have server-side rendering enabled, because then you can't walk along the DOM anymore if it's server-side rendered. And Vue 3, and also minor versions in between, even improved the VDOM by using compiler hits. So some of them you see over here in the JavaScript code. For example, it says need patch. So that's a signal that, okay, this node will need an update. Or stable fragment. Okay, this fragment will not change. Text. So in that sense, the VDOM can be optimized. But the problem is that the VDOM can only be optimized to a certain degree. You still have to walk the whole tree to update certain parts. You maybe can skip things or memoize, cache, etc. But there are limitations. So Vapor mode is there. And the approach is inspired by Svelte and Solid, and more or less doing what we do in our script part, but in the template part. You will see what it means in a sec. Let's have a look. To enable Vapor, all we have to do is write Vapor up here. And you'll see the code will change drastically. Now, the interesting part, this part here, right, the setup function, this will stay the same. So our script part is not changed. As mentioned, Vapor mode only influences how the template part is rendered differently. So what we see now is here we have T0 template. So in this case, this is just taking the template without the interpolation. So okay, we can use that as blueprint. Same with the input here, T1. Funnily, if you'd write another input here, then we would not have another T2. It would just use the same, because it is literally the same template. It would be different if we write like class ASB here, then we get another new template. So reusability of templates is quite important here. Okay, and now we have a render function. We also had render functions before, but these are quite different because once again, they're not VDOM based anymore. Now we have these templates and we create instances or nodes out of them. So N0, which is this H1 here, N1 from T1, which is this input vModel message that will, at the moment, it's just an instance of input, right? Same for N0, that's just an instance of this. There's nothing happening with it yet. And N2, which is this part, it's also just that input template invoked. Okay, and next, of course, this N0 here, we need a child, we need some information that we pass down there. So we create an X0 here, and then this X0 is used to render an effect. So whenever the context.message changes over here, it's formatted to a display string, then please set the text. So change it. Change the text of X0 of the child of the instance of this wonderful H1 tag. And render effect sounds familiar, right? As just mentioned, this is more or less the same concept of using refs, reactives, or just say signals, fine-grained reactivity in the script part, but doing the same now for the templates. So instead of walking down the tree, you can easily track effects and changes per element. You can reuse a lot of things and you have a lower cost, especially with a lot of nodes that you don't have to walk down the tree all the way. And they can act independently, so to say. Of course, there's a bit more behind that, and also directives like vModel are applied here to say, okay, for N1, we want to make sure, all right, let's get the value here, context.message, and when there's a value coming from the input event, then we just want to set message to the value. So all of this will, of course, work as expected. Here nothing happens because nothing is bound. Do a data binding, and we're good to go. So that's the idea of Vapor mode, more or less, to have this fine-grained reactivity as part of your template. Compared to, removing this once again, here we see, okay, this is a render function too, but it's a bit more virtual DOM oriented. So we have an element block, then we create a virtual node. We also have the toDisplayString, etc. We say, okay, with directives, we render this node, and so on, so on. We can also still cache things. So as mentioned, the compiler can optimize the VDOM, but you still have this tree-like structure here, where you don't have that with Vapor. So, okay, now you know there is Vapor. We do things with fine-grained reactivity and it's faster. But how fast is it actually? And to judge that, we use the good old JS framework benchmark. That's, I think, the most well-known JavaScript benchmark in the ecosystem. And we've selected a few frameworks, including vanilla JavaScript. And here we have certain operations. So they're measured based on how fast they can, for example, create rows, 1,000 here, replace rows, etc., etc. And then we have different frameworks: Svelte, Solid, Vue Vapor, Vue, Angular, and React. And at the end, we get a score. Some operations might work better. Some, for example, like swap rows, work horribly with React, apparently. And in the end, we get a weighted geometric mean of all the factors. We see vanilla gets a 1.02, which is pretty amazing score. Then we have Svelte and Solid, with Svelte with 1.10, Solid with 111, and then Vapor also with 111. So on par with Solid here, and almost as good as Svelte. And then we have a big gap to Vue once again, right? The plain Vue, by not just like 0.01 between Svelte and Solid or Svelte and Vue Vapor, but actually between Vue Vapor and Vue, it's 0.15. So it's quite a bit. Of course, still React and Angular are a bit further behind. Nevertheless, that's not the point here. And it's important to mention, yes, these benchmarks are important. And of course, you want to have a fast framework. Also, likely your API call, your images, your tracking scripts are way worse. So picking a framework just based on numbers, not necessarily the best idea, but it's still part of knowing that. And it's of course also inspiring authors to get better and better. And not everybody has the newest iPhone or MacBook or Android phone. So we have a lot of people with low and mid-tier devices where Vapor mode, for example, will also help a lot. But wait, that's not everything actually. First of all, if you noticed, this is Vue Vapor 3.5.13, so this was a work in progress branch. The newest alpha has not been tested yet, so we have to wait there a bit, but Johnson did a little comparison. Here we have now vanilla.js, Vue Vapor, and a working branch. This is also not the alpha yet. This is still a work in progress branch. And Vue Vapor 3.5.13, what we've seen in the benchmark. He ran the code locally, and the result was vanilla JavaScript got a 1.0, Vue Vapor normal got a 1.10, so that's almost equal to what we've seen there. And Vue Vapor working branch on a 1.06. So that means it's even faster than a Svelte or a Solid, at least in that benchmark. And as soon as the alpha is tested once again, results will be linked below. But there is a very good chance that Vue with Vapor, for the first time ever, becomes the fastest modern framework in the JavaScript ecosystem. It never was, but now it might be. So that's pretty exciting. Even though I just said, yeah, these numbers are only partial part of why I should choose a framework, we can't complain about the framework getting better, right? And then once again, this will also benefit the ecosystem. People look into that, might also take over some approaches from alien signals, etc., etc. So it's a net positive win. Okay, but Vue Vapor is experimental and it's part of the Vue 3.6 alpha, so it's important, it's also written here, that it's still incomplete and it's unstable during the alpha phase, right? So the idea is use it, do compatibility testing, but be aware that there might be points that do not work yet. The team also recommends using the Vapor mode in following cases, either building small new applications, so like what we did, tiny, or we have an existing application with a big need for improved performance. So just take this part, this, let's say, subtree that's perf sensitive, and migrate it all to Vapor. Migrating existing components over to Vapor is not recommended at the time of recording. That might change later, especially when the alpha phase is over. Another reason for that is also because not all the features are actually working yet. So while there are some, and we'll look into that in a bit, that are deliberately out of scope, things like SSR hydration, async components, transition, keep alive, and suspense are not ready yet. 4 of the 5, they have a pending PR, which is great. Suspense, well, it's not stable yet, right? We're also waiting for that for a bit. Let's see when that will come. But that's also not available now. And without SSR hydration, it also means it doesn't work with Nuxt yet. I suppose that means it doesn't work with Nuxt with server-side rendering yet, because you can also build just SPAs with Nuxt. That should work fine. Talking about how did we actually use Vapor mode, because we know, okay, we can opt in through script setup Vapor. We tried that. That's lovely. Even though in a way, it's more like template Vapor, but still, that's the way of setting it. How else? And there is a very important part. There is a Vapor interop plugin. So if you don't want to create a Vapor app that only uses Vapor, of course, lower bundle size because there's no runtime code for the virtual DOM, you can still use it in your application. And for that, you need to use the Vapor interop plugin that's provided through Vue from this alpha on. That means you can mix and match these VDOM normal components and Vapor components, but as mentioned in this big paragraph here, there might be rough edges around it. And what the team is not recommending to do is nesting them differently. So like have a VDOM component and then Vue Vapor and then VDOM, then Vue Vapor. Just as mentioned before, pick a subpart of your application and from there, from that component on, everything in Vapor, that's it. Also, some VDOM component libraries, running them in Vapor might cause some trouble, so same idea. Just take the perf relevant part and migrate it all to Vapor. Next thing important to mention is the feature compatibility. So of course, Vapor mode supports a subset of existing Vue features. You don't have to learn a new API, but that also means things like the options API are not supported. That was also clear from the beginning, and that's fine. Interestingly, also get current instance will return null in Vapor components. So this could possibly influence some component libraries and maybe also hacks in your code base. So keep that in mind. Also other things like $slots, $props not available, and some add view per element lifecycle events, which you probably shouldn't use anyway, right? Last but not least, also the directives have different signature now in Vapor mode, because I can actually use things like watch effect in there straight away, very similar to what is happening under hood templating too. Eventually, keep in mind, it's still alpha, so there might be some inconsistencies that will be fixed. If you see anything, don't forget to report it and mention it. And now it's time. How can you try out Vapor mode? Well, the easiest is just install the alpha, either through a new application, spin it up, or an existing one, try it out, add the interop plugin as just discussed, and then script setup Vapor away. For this week, that's everything we can cover around the alpha. It is so nice to see that after a lot of time planning and execution, thanks to all the contributors, Vapor is available now in the alpha. I'm so excited to see how the bigger community will receive this wonderful new compilation mode. Let me know your thoughts in the comments as usual. Any questions, any problems you might see, or suggestions as well. And other than that, I can only say enjoy Vapor. We have a lot of things to talk in next week as well, just mentioned at the beginning. Thanks also to Henke for sponsoring this video, and have a lovely day. Happy hacking.